This video is long and that's intentional. I'm going to walk you through how I planned and built a save system, how I broke the problem down, how I made the decisions, and how I wrote the code step by step. There are no shortcuts. You'll see both the thinking part and the implementation part. This is going to be really useful if you're a beginner and trying to learn how to implement systems of your own and how to create modular code. If you want to follow along, grab a cup of coffee or tea. This is a slow, practical walkthrough. You can pause as many times as you want to learn something. I created a saving system called Anchor Save in the previous video, and we are going to try and create that particular template or at least the base of that save system on our own with modularity in mind so that you can learn what exactly is happening and do also cool stuff in the future. Before we touch code, I want you to be clear of what this video is and what it isn't. This video is not about copy and pasting this code into a project. The goal here is to how to think about developing a particular system. In this case, a saving system. This is going to be an educational video more than a tutorial kind of video. It's a walkthrough. It's like a mix of a walkthrough and a workshop. How to make something that feels like big and messy and too complicated to start, and you turn it into something small and controllable. If you only watch and don't write code, that's fine. If you pause and build along with me, that's even better. Okay, now how do we build a system? This is where a lot of people fail to start, right? Either they don't start because they don't know how, or they deal with everything all at once, right? These are two of the main reasons why people don't continue with projects. I want to address this by having a simple solution for this. If you are following along, this video will also contain exercises so that it's actually educational and not just, me showing you the answer. But in the beginning, let's talk about a simple problem solving strategy. Divide and conquer. This is probably the most powerful problem solving strategy that I use, and I don't use it intentionally, but I used it more than enough that it becomes subconscious. And here you take one big problem and then you divide it into individual smaller problems, and then you conquer one problem at a time. And how do you conquer that one problem? You again then divide that into smaller, simpler problems. So this continues until you conquer all of those problems, and then you finally conquered the base big problem. So this is what we're trying to go for. And there are also intricacies like how do you divide and stuff like that. We'll look into it. Okay. So in this case, we have something called a save system, which is the thing that we're trying to build. How do we start to divide this whole problem, right? And in my opinion, the easiest way to divide a problem is to reverse engineer it. Meaning, in the case of game development, you start with input. What actually causes a trigger for this system to work? In this case, we have input, right? When the player hits save, we need to save. And the player hits load, we need to load. This is going to be our problem number one. Try to get a save and a load working. Try to get the input working. Okay. Now we have individual problems within this. So let's focus on saving. Okay. How does saving work? Essentially, in save systems, you save to a file. Okay, this could be a binary file or a JSON file. We have to make that decision. Let's call this write to a file. It's as simple as that. Now we have two problems that we can solve. All of a sudden we have this structure, right, which we can work with. And then what's next? Load. And here we read from a file, right? It's as simple as that. We read from a file. That's what loading is. But it's also another problem. So that is restore data back to Let's call it entities. So now we have 4 different things. We may add a fifth, or we may add a problem in between. Okay, I want you to use pen and paper or Krita or whatever you have to draw it out like this. This is going to be really helpful. Okay, so whenever you think about any new system from now on, try to draw what you're trying to build and try to start with input, and then you go forward. Okay, and then you can always add to this later. You can add more problems, you can divide this a lot more. You have full freedom. Because it's a longer video and I don't want to waste a lot of your time, we're gonna focus on a little bit of these. So now let's focus on the very first problem, that is input. So if we press save, we need to save. If we press load, we need to load. All right, so I recommend creating a new project. Even if you're working on an existing game, start with a new project, because we are trying to build a modular code, and then we can export it as a package and then import it to your own custom project once this is done. So you are not messing up your own existing project. Okay, so let's create a folder. Let's call this SaveSystem. There we go. Now, how do we create folders? And I recommend creating a folder called runtime. Okay, this is the folder that contains scripts. Why do we call it runtime specifically? It's based on Unity's custom documentation folder structure. Unity has its own documentation for package layout, and it contains all of the folder names: package.json, readme, a changelog, a license, an editor folder, and a runtime folder. You can also have tests and samples, but with a tilde symbol. That's important. So all of these names are really important when you're creating your own package. Okay, it's not mandatory, but this allows you to create a UPM package as well. This is great if you want to upload it to Unity as a store or sell it somewhere or something like that. And now let's look at this. Input is something that is local, right? It's not a part of SavingSystem, but this is a trigger, right? This is dependent on the game that the player plays. So this is not a part of the core runtime. This is a part of the samples that we can provide technically. So I want you to get into the habit of thinking ahead and then creating a folder called samples. Samples ideally will contain a tilde symbol at the end, but we're not going to do that right now. You can actually just simply create a folder called samples. If you add a tilde symbol, this may be recognized as a hidden file, especially when you put it into packages if you're trying to create a UPM package. So I just recommend normally writing samples. It's fine. Now let's create a script. Okay, a mono behavior script. Let's call this save input. I don't know. Now this is where drawing it out makes it simple. We just have 2 functions, save and load. That's all we need. So we can write public void save and also public void load. Okay, so these functions will save and load, and just temporarily we are going to debug.log saving, debug.log loading. Really simple. Now how do we call save and load? You can use your own ways of input. I personally like to use context menu attribute, and I'll call this save. It's a very simple way of doing things. Now if I create a player on the field, so right click, let's create a 3D capsule. I'll call this player, and let's add the save input component. We can now click on this, and then we have the option to save. Okay, and if you click on it, saving works. This is one way of doing this, but let's actually show you the input way. Now, because we are creating samples and we have to use the input system, we have to create our own input logic. So inside the runtime folder, an input is something that is not belonging to this package. So it will not be inside runtime. It will be inside samples. So let's actually create another folder here called input. And let's also create a folder called scripts. Let's drag this folder here. And inside input, we can right click, create input actions. Let's call this save input controls. I don't know. Let's double click to open it. Now we have an input system actions editor. I have a video. I'll link it in the description if you want to learn more about the input system. I have a whole playlist. So I'll link the playlist actually. Now you can click on action maps. Let's call this saving or something. Usually you have a player or a UI action map. Just save to that. New action. Let's call this save and let's bind this to F5. Okay, I'm gonna click on listen and then F5. We have a save action. Let's also create a load action. Both of these are action type button. Okay, because when you click on them, you need to perform them. And here, let's add a binding. Let's listen and load on F6. You can also give your own custom keys. Now hit save asset. You're done. Okay. Now the only thing that I'll do is we generate C# class, hit apply, and the class name is called SaveInputControls. If we hit apply, it will create a C# class, and this is something that we can use in packages because now this is an external class. Okay. Now let's go to our SaveInput class and write SaveInputControls. That's what it is, I believe. Let's call this controls. Okay. No errors. IntelliSense is working bad today. I don't know why. So we now have a controls as right equals new SaveInputControls, something like this. Now because we are, let's create a void on enabled, let's say controls dot enable, and on disable controls dot disable. It's a very simple and straightforward way of doing things. Let's close this thing here, and on awake, now we already have spoilers. Controls equals new save input controls, and then we're gonna say controls dot, what is it called? Is it save load? Saving dot save dot performed plus equals ctx. This is a lambda expression. You can also do it like this if you want, but this will give you an error because there's no save function with the proper callbacks. Okay, so if you save now, it will give you an error. Yeah, this one here. No overload for saves matches this delegate. So you can actually add this to your liking, but because we don't have anything to do with context, like you can do the saving and loading. Similarly, controls dot saving dot load dot performed plus equals ctx lambda expression load. So the disadvantage is it might add unnecessary namespaces. Understood. And I also forgot adding curly brackets to it. So now there might not be any errors. So there's an error in save input CS6. So this, we're not allowed to do this here. So just call it controls. Okay. So we're not allowed to do the new controls here. All right. Now we have a save input class with the player, and the player is in the field. It doesn't have any player input component or anything. This is just C#, pure C#. Let's hit play, and I will go to the console, press F5, and now it is saving. F6, it is loading. Yay, now you can save and load whenever you want. So now let's go back to Krita. All of a sudden, we have completed this problem. And now we have progress. If we were to think about how saving and loading works, if we were to do everything once, we would have been overwhelmed already. Now we have a clear progress. Now we only have 3 stuff remaining that we have to do, right? That is saving and loading. Let's try and tackle saving. Quick pause here. This feels like a good breaking point. Everything I'm explaining in this video is mostly about how to think and not just writing code. If you're working on your own Unity projects and you're feeling stuck, maybe your systems are messy, maybe you don't know how to break a problem down like this, I also do private one-on-one Unity sessions. We can do it on Discord, video call, or any medium that you prefer. The sessions are usually 1 to 1.5 hours long. Pricing depends on the topic. It starts at 1,500 rupees per session, and it goes up for more advanced systems and architecture work. This is mainly for beginners to intermediate developers, for those who want feedback on their systems or like their project, or if they want to learn Unity from scratch. If it sounds useful, the details are in the description, or you may comment down below. I respond to all comments. Cool, let's continue. So how do we save? We need a class, right? called saving system or whatever we want. But this is core to the package, so we'll put it inside runtime. We'll create a mono behavior script. Let's call this saving system or something of your choice. This is what will contain public void save game, public void load game. Okay, VS Code is suggesting it, so I'm just going to use it to save time. Okay, and now in the save input, should we use save game and load game? No, actually, let's actually rename this to save game to file and load game to file. This is a much better way of handling things. So what's the difference? Let me explain. So now we had input. If the input were to call a saving system and it will call save and load, the problem is if we were to build upon this to actually add more features like slots or autosave and stuff like that, saving system will be overwhelmed with too much tasks. Okay, so instead of depending on a save system, which is bad, let's actually depend on a save manager. Okay, this is a separate script that will manage how saving works, and that will talk to the saving system. What is the advantage? Is because this can be customized based on your existing game. Okay, but this remains same. Let's say you have auto saving in your game. Now you can configure the manager, okay, to have both auto saving and normal saving if you want. Okay, that is completely your choice. We're not going to add auto saving or anything like that. It's very straightforward. That is your task. If you want to build upon the system, we're just going to focus on simple saving and loading for now. But the core logic of saving system will be the same, when the save manager can be customized. That is the advantage. So let's also create another mono behavior script, save manager, which gives us the option to actually not make this a mono behavior if you want, and it is completely fine. Okay, this is completely fine to not make it a mono behavior. You can make it a mono behavior, it's up to you. Okay, I generally recommend trying not with a mono behavior to challenge yourself. Okay, let's do that. Now let's go to the save manager and let's have a saving system equals new saving system. Okay, now before we proceed, there's something important that I had to tell you guys, and that is to use namespaces. I forgot about it. I should have done it in the beginning. So we create a namespace. Let's call this saving system dot samples, and let's add it here. Select all, then here's a handy shortcut. Control K and Control F will clean your code, add proper indentation and everything. The same goes for save manager. This one is going to be a different namespace. Namespace saving system dot runtime. Makes sense. Control K, Control F. It will save. Same goes for saving system. Namespace saving system dot runtime. Control A, Control K, Control F. So let's public void save, just save. And we call saving system dot save game to file. Let's also add public void load saving system dot load game to file. Very straightforward. And now here we get a reference to the save manager. Let's call it save manager. Now because this is in a separate object, let's use start. If save manager is in the same object as of save input, we write it on awake. We say save manager equals find object of type save manager. Also, if you're wondering what is doing these IntelliSense, I have a VS Code extension called, let's search for Unity. It's called Unity Code Snippets. You just install it and it's really great. Plus, I believe VS Code uses OpenAI to help you with coding and stuff. So now, instead of saying debug.log saving, let's call save manager dot save. Here, save manager dot load. Really straightforward, nothing too complex. Let's also do some checking here. If I don't even have to write it. If save manager equals null, we just log an error saying, hey, no save manager is found in the scene. So now we actually have a good system in place. Now we can customize the save manager and we can customize the saving system. Okay, now we need to be able to write to a file. But you can see the time is 7:26. It's been around 43 minutes, 41 seconds of recording. I have to take a break. I have to go to the gym and I'll come back and then we'll resume it. Now, I also recommend you to save the game, save your project, sorry, and then let's take a break. Cool? I'll see you. Okay, I'm back. So, how do we proceed with saving? How does it work? Well, we discussed we need to save to a file, or in other words, we need to write to a file. But what sort of file should it be? One is player prefs. Okay, player prefs is something that Unity by default implements. Player prefs is like Unity's built-in saving system, but it's very weak and it's prone to a lot of issues. It is completely string based, and it's not just string based, it is manual string based. So it's a bad way of saving. Okay, so we can just completely ignore that. The second way is to write to a JSON file, and JSON file is a valid option because the way it is formatted allows us to save data of entities in a particular format, and it is extensible, meaning we get to control what is being saved, okay, and how it is being saved. The downside is it is string based, which is not a big issue, but the thing is cheating is possible in JSON based saving files. What do I mean by that? A player could access the save file and then change the values directly because it is human readable, and it is easy to cheat, okay, but it is a good thing. It is a good thing for indie developers. If you are AAA studio, you should look into a better type of saving system because cheating allows players to tailor our game to their own experiences. Also, modders will be able to pour their craft into our game as well. So, which is actually a good thing. It increases the popularity of your game, especially for indie. You should allow players to cheat. Another way to save is save to a binary file. Now, I used to do this a lot until I realized there are a lot of security vulnerabilities when it comes to the way in which we save things. I used to use something called the binary formatter, which is actually a bad way of saving. Microsoft recommends it is a bad way to save. Instead, a better approach is to look into something called the binary reader and binary writer. This is much better than the binary formatter. If you are looking into saving into a binary file, this is one way to do it. There are other ways to do it. You can go to C# save to file as binary. You can save as a byte array and then return it back. You can use binary writer for primitive types. It's not great with better things. There are a couple more classes that I've read. It starts with the data, something I don't remember the name, but binary file is very safe. That's the best thing. But encryption and decryption needs to be very solid, especially if you're going for competitive multiplayer games. Okay, so encryption and decryption. These are the two things that you need to look into. So we are going to use the JSON file approach, which is very easy and it is extensible. It is simple, right? And it's used for indie games. You can, however, look into a binary file approach, which is a lot more tough. It's very less debuggable, meaning because everything is saved in binary, you won't be able to understand what is not saved. Because the way we are doing it is in JSON, the characters are in English for the most bit, and you can just know that something is not being saved or something is going wrong. It's easier to debug problems with a JSON file. But a binary file, you don't have that. And you also need to look into strong ways of encryption and decryption so that people can't misuse it. So it's a lot more work. So we're going to go with the JSON file approach. Now, again, back to the problem solving aspect of things. How do we write to a JSON file? So again, drawing is the best way to solve things. So how do we know? We need a save file, right? Let's call this save file. Okay. This is going to contain JSON formatting, meaning it is essentially strings, a bunch of strings. It's going to have JSON formatting. Let's call it a save file for now. The saving system must contain logic to write to this file and also read from the same file. You can see it has a lot to do with the save file and the saving system. So a saving system needs a save file. Does that make sense? Now, how do we know a save file? We have something called a path. Okay, so the saving system can access a file at this particular path or directory. So the path is going to be a big factor here. Now, what exactly is JSON? Let's look into that as well. Now that we are here, let's look into JSON formatting. And if I go to Wikipedia, you can see it is like this. This is an example for JSON representing a person. So the first name is John, last name is Smith, is alive, is true, age is 27, and you can see this is how formatting works. And it's important because not only we need to save to a JSON file, if you were to create it into a package, we'll need to learn how to write package manifest file, which is also in JSON. So this is actually great. But you can see the formatting is very weird. You have a colon in between and you have something on the left and something on the right. What if we can take advantage of it? What if something on the left is like the name of the game object that we want to save? If you take a look at the phone numbers, you can see that phone numbers is like this, but it also has a type and a number inside it. So you can use these brackets and then colons to divide your data into different, IDs. So what if phone number is a struct or a data type, and type and number are just fields or like properties in that struct? So what if instead of first name it's like player speed, and instead of John it could be 5 in a string? Then we can convert it to an integer if we want to. What if instead of phone numbers it is like PlayerSaveData, and then instead of type it is the position of the player, and here is the number of lives. So this is the format that we want to save, which allows us to debug this very easily. Okay, apparently there are some errors while opening Unity. SaveManager could not be found, and that is because we are in a different namespace. So save input needs to use SavingSystem.runtime. Just hit save and the errors will be gone. Okay, it's called SaveSystem, not SavingSystem. And the errors are gone. You can also see find object of type is obsolete. I allowed VS Code to complete this code. So it should actually be find first object by type SaveManager. That is the newer, better version of find object by type. There you go. Now with the save system, let's actually create our own save file. Now a save file is not something that you attach to a component, right? It is a class. This makes sense. The same goes with the saving system if you want. For the saving system, it is completely optional. You can also inherit from mono behavior. That's completely fine. But I just do that just because it's obvious that there are two classes. You don't always have to completely rely on code. And people can separate out their save manager if they want to. So this is one way to do it. Public string file name, public byte file data. But what if a file doesn't need a name? Because there is already something called the path, which we talked about. The path should contain all of these things, right? So what if the save file class contains the things that it needs? But before we look into the actual thing that we want, let's actually put it inside a SaveSystem.runtime namespace. Now what does it need? A file name, save data, makes sense. But is that exactly what we need? So if you look at Wikipedia here, we need a bunch of different things. So you can see that you have an ID, and then you have the JSON or the string. You have another ID, you have a JSON, you have another ID, JSON. Even inside complex things, it's still IDs and JSON, IDs and JSON. So this IDs and JSON thing is something that is common for all of these things, right? So what if we can just, create a struct? Let's call this save entry. This is the same class name that I've used in my package. So now we can have a public string unique ID or UID, and then we can also give it a public string. Let's call this JSON data. Great. So now every save entry, this should be a struct, apologies, contains a UID and a JSON data. And inside the save file, it should contain a list of save entries equals new list of save entry. Because we have added list, we need to add using systems.collections.generic. No errors, that means nice. So we have a save file which contains a list of save entries, and each entry will contain a UID and JSON data. Okay, and JSON data can also contain UIDs and JSON data inside it. All right, just to be safe, let's mark these things as system.serializable, the save file, and also the save entry struct. Otherwise, they may not be written to a file. And there we go. We have a saving system. We need a reference to the file, but we don't have to save a reference to the file itself. We need a reference to the path. Let's call this string path. Okay, very simple. In the save manager, we can actually serialize field private string save file name equals save file dot sav. This is completely up to you. You can even give it a custom extension as well, and then use string operations. Just for the sake of simplicity, I'm just going to give it save file dot save as the save name. Now it is going to call the save game to file function, and now we can just pass in the save file name as the thing that we want. So go to the saving system. Let's actually give a file name, and now AI has spoiled it for me. We need to actually give data to this path, and this is how you do it. You say path equals application.persistentDataPath plus this thing, I don't know what it's called, plus file name, and then you have a debug.log game saved. I'm just going to keep it temporarily. So now we have assigned the path. What is application.persistentDataPath? This is like the root folder. Okay, let's actually look it up. Is a read-only string property that returns a platform-dependent path. So in the case of Android, it's going to give a different path. In the case of Windows, it's going to give a different path. In the case of Linux, it's going to give a different path. So it's completely platform-dependent, but it will give you a persistent path. Okay, but the problem is, how did I know that such a thing existed? How did I know of these things? So as I say, Unity, where to save files, and then AI overview thanks to that. Otherwise, you need to actually go through each of these blocks. But thanks to AI overview, it says application.persistentDataPath is where typically players save things. A hidden system folder like Cape Data or local on Windows, ensuring app-specific persistent storage for player progress. Great. Application.persistentDataPath. Then you go and read more about it. That's how you learn. Okay, so that's the same thing that we're going to use. Path equals application.persistentDataPath plus file name. Now I have an exercise for you. I want you to implement this save game to file function on your own fully, like even with JSON. Now you might be here to learn how to do it, but the activity, if you're following along, is to just try it for yourself, because more often than not you'll be able to do it. Okay, I highly recommend not to watch any YouTube video. I don't recommend you to, use ChatGPT or anything like that. It is possible, but don't use that. I want you to use Google. Okay, I want you to manually search in the search bar. Apparently, AI overview will give you time, but hey, that's fine. But then I want you to go to the documentation and try to read what's happening. Okay, so how to write to JSON files Unity. Okay, you're not going to watch any video on it. So the AI overview will give you a very good explanation. It tells you to create a save data class which contains the things that you want to save. And now I know this because I've done this a few times before. And you just handle the serialization somewhere. You can say just file.write all text. And we give in a save path, which is the path that we already have. And then we need a JSON string, which is a JSON formatted string. Now that is a string called JSON string, which uses JSON utility.toJSON function. It's as simple as that. Okay, so pause the video now and try to do saving on your own. So let's actually create a string. JSON string equals JSON utility.toJSON. We need to give it a current save data, and then we need to give true or false for indentation. We don't have any current save data, so we are at a problem here. How do we get the current save data? So let's go back to Krita. Right now you've hit another wall. The problem is, if you draw it out, you might be able to solve a lot of your problems. So this might be place where you might get confused a little bit. How do we get player save data for everything, not just the player, the enemies, and everything like that? So let's actually draw it out. Let's say player, let's say enemy 1, this is enemy 2, let's call this settings. All of these things needs to be talking to the saving system. So one way is for all of these to have direct references to the saving system and then save, which is possible, I guess. It sounds bad. Or the saving system needs to find all of these things individually and then save their data, which also looks bad by design, because why should the saving system know anything about the player? They're two independent things. You don't want unnecessary coupling. Now, the way to solve a lot of your problems in programming is to use interfaces. Okay, what if we created an ISaveable interface? All of these things can implement this interface. The player, enemy 1, enemy 2, settings, all of these will implement the ISaveable interface, and then the saving system only looks at things that implement this interface. It does not know that it is the player, it does not know it is the enemy, it only cares whether it is ISaveable or not. So that is the approach. Several problems could be solved by just adding an interface in between. Adding a third in between class or an interface will solve a lot of your coding problems. Okay, in this case, interface is more than enough. So let's actually create an interface. So runtime, let's create a mono behavior script. Let's call it ISaveable. Let's actually write a namespace system.runtime and not a saving system, but let's create a public interface ISaveable. So what does any ISaveable thing need? Sorry for the spoilers, AI is spoiling everything, but it will save you a lot of time. What does each object, let's say the player needs? The player needs a unique ID, because the JSON file needs to clearly represent that, hey, this data belongs to the player, and hey, this data belongs to entity or a game object with a very different unique ID, which could be just random numbers or characters. So the player needs a unique ID, and it also needs something to save the data. So a unique ID and something to save data. So we can say public string UID, and we can explicitly make it only get, meaning we cannot be able to set it. And also public, let's call this capture state. Okay, so we have a capture state function and a string UID. Okay, so I'm back. Sorry, I had to go for lunch. Right now, there's a problem, because capture state cannot simply be just a function. Like, what do you capture? How do you capture? So this needs to be called somewhere here, and what we return should be written to JSON. So there should be something that we need to use here, which means capture state should not return a void. Instead, it should return something else. In my opinion, it should return an object. An object could be in anything. It is the system.object class. It supports all class in the .NET class hierarchy, which means all classes could be converted into an object. Okay, this is what we are going to use. Now, the advantage of using the interface is that now we can actually filter through all objects that implement this interface. I want you to pause the video again and use interfaces to perform the saving logic this time. I will see you once I finish writing my code. Now, this is the function for saving a game to a file. We have not fully finished writing to a file yet, but we have created what we need to save, and then we'll focus on writing to the save file together. We firstly created a save file, which is this list of save entries, and save entries contains a UID and a JSON data. Okay, and we set save file equals new save file. This simply means we created a new save file. Okay, then we set the path. We talked about this, Application.persistentDataPath, and we get the file name. File name is from the SaveManager here. Okay, then mono behavior array mono behaviors equals object dot find objects by type mono behavior find object sort mode dot none. This just simply scans all mono behaviors available in the scene and then assigns it to an array. Very simple. Next, inside a for each loop, for each mono behavior MB in mono behaviors, we're just iterating through this array. If MB is an ISaveable, and we're just temporarily calling it ISaveable, which means if this MB is implementing the ISaveable interface, then we say object. Okay, we're creating a type of object because this ISaveable capture state also takes in an object. State equals saveable dot capture state. Now each game object that implements ISaveable will have its own individual capture state. It will return its own data type. Okay, and that we are storing into an object called state. And then we created a string called JSON. Okay, JSON utility dot to JSON, we're using it here, and we are passing the state. So the state that we just received, we'll just convert it into JSON. Okay, and we're storing it inside the string called JSON. Then to the save file that we created and to the save entries, which is the list of save entries, we are adding a new save entry which has a UID, which is saveable.uid. Okay, saveable.uid is a public string UID, and then JSON data equals this JSON string, and then we're done. So for each ISaveable, we're just adding the save entries, and at the end we created a big string which is called JSON string equals JSON utility dot to JSON, the entire save file. So we're adding each entry to the save file in JSON format, and then we're converting the entire save file into JSON format once again at the bottom once everything is saved. Okay, and now we have a string that we can write to a file. Now let's write to a file together. And I believe we looked into this. We just simply write file dot write all text path, and then we specify this whole JSON string. This is the line that does all of the writing, and then we are done with this saving system. But there is a hidden problem. Okay, this is why I'm doing the writing thing at the very end. The hidden problem is this file could not exist, or this path may not exist. There could be something wrong. Maybe the save file is too big. Maybe we are out of memory. A lot of things could happen. So how do we deal with all of these different exceptions? I'm just going to show you how to do that. And the easiest way to figure out exceptions, or if we are running out of any problems, especially when we are writing to a file, we simply put everything inside a try block. Okay, we're gonna press Control A, Control K, Control F to make everything clean. Now we put the entirety of the code inside a try block. So whatever code that we put inside the try block, it will be special, and it will always check for any exception if occurred. In this case, exceptions may occur in this file.writeAllText, and maybe it may occur here as well in this find objects by type, maybe. But it's not done yet. Once we try, if we catch an exception, so we write system.exception, let's call this exception E. If we catch this exception, we are going to log an error called E. This is going to print to the console what the exception is. Okay, really cool. So we have a save file, we have a SaveManager, which has a function called save. Okay, and now the save input simply calls the save function, which calls the SaveManager.save. But here again, things could go wrong. What if in the SaveManager we did this, right, and it caught an error, but we need to be able to be sure inside the save input, or we need to be sure inside the SaveManager that we have actually done the saving, because something else could happen later. Let's say we need to call an event or something like that, or we need to update something. So we need to make sure inside the SaveManager it is possible to be able to get the data back. So in that case, we are going to not make this a void, but make this a bool. The same goes to a load game. We can check whether loading or things is successful or not. So in this case, we can just return true here. But in the case of save game to file, if we catch an exception, we can return false. Here, once game has been saved, we can return true. So now inside SaveManager dot save game to file, we can put it inside one giant if condition, and we can say save successful or save failed. The same thing goes for here. If SaveSystem dot load game to file, load successful, load failed. Now we don't need this debug.log because SaveManager will do it for us, and the same goes here. Now let's see if our save game is finally working. But how do we save the game? Let's create a very simple player. Okay, we already have a player. Let's create a player script, but apparently we have errors. Okay, the class name file does not exist, and I believe you need to be using system.io. I believe that should, yeah, fix the error. Now the namespace exception. We just need to use system because it's system.exception. Now there's a problem here at line 50. Again, errors all the way. It's actually line 20, sorry. Object Unity engine dot object. Now for some reason Unity engine dot object may work. Yes, it worked. Great. I did it manually, but it didn't work for some reason. Cool. So now let's actually make a player. So let's create a ground. Let's move the player here. Let's scale it up. Now let's add colors to this. So I'm gonna create a folder called material inside the samples, because this is not the part of a saving system. This is a part of a sample, right? Create material. Let's call this player. Bada bing, bada boom. Let's give it a color of pink. Now let's create a script for the player controller. Bada bing, bada boom. Let's go. Now we just need to move the player based on input. Very simple. Let's serialize field. Move speed equals 5f. Let's go back to the assets. Let's go to this original input system. Let's copy this move action. Let's go to the samples. We have an input system here, and let's add a new thing called player. Let's paste it. Let's delete the first action. There we go. We have a save and a move, and it is all inside a C# class, so it's great. It's called save input controls. Okay, save input controls inside awake. We can say controls equals new save input controls. Let's say controls dot player dot move dot perform move. Let's public void on enable, public void on disable, and then void move, which takes in a vector 2 direction, and we just move, okay, on the input. Really great. AI is really great for saving me time. So this is just a player controller which just moves forward and backward. Let it load. No errors on the console, which is great. And the player should add a component called player controller. Move speed could be 5. Let's go to game. Let's actually keep it something like this. Select the camera, Control Shift and F to move the camera to the scene view camera. And now we can play the game. No save manager found in the scene. There's an error. Great. And that belongs to save input, right? So let's create an empty, call it save manager. Let's add a save manager. Really cool. Now if we play the game, hopefully it is moving only once. It's not moving all the time. We can fix that by using the update function. Temporarily, we can say vector to move input is equals players controls.players.move.read value vector2. This is going to get the vector2 out of the move action, and we're just calling the function move, and we're directly giving it move input. This should work every frame. And now you can see the player is moving. We can press F5, save successful, F6, load successful. These are just debug commands. Okay, but the save file may have been created, but we'll look into that. So once we do write the text, we can write, hey, we saved save file this many count entries to the path. This will also display the path in the console so that we know that the save file has been created. So let's actually test it out. Let's play the game, hit F5, and now you can see, because I'm in Linux, this is my path, so I can click on it. Let's see if a save file has been created or not. I'm gonna copy this, and I can see that a save file.sav has been created. It's only 25 bytes. If I open with a text editor, you can see nothing is there, but save entries has been added, so it's great. Now we need the player to be able to save this data. And how do we save the data? We simply implement the ISaveable interface. Now ISaveable is inside a different class called using SavingSystem or SaveSystem.runtime. Let's actually put this inside SaveSystem.samples. Now because ISaveable interface has been loaded, you can see there's a bunch of errors. Player controller does not implement ISaveable.uid. Now the errors come in. Let's quick fix implement interface. This is going to firstly create a new string uid, and here we can just say player, because right now this is the player. This is the unique ID for the player. There's only going to be one player in the game, right? It also must have implemented a capture state function which returns an object. So what can this object be? It can be anything, which means we can create a custom struct. Okay, let me write it. Custom struct for player save data. Let's call it, I like it when I'm doing it, but I hate it when I'm teaching it. It is one of the biggest ups and downs about VS Code, especially in Linux. So public struct, let's call as player save data. Even if this thing is shown to you, just type over it rather than just copying it if you're learning. Now we only need a position. Aha, you got this wrong. The thing is, you cannot simply just write vector3 position, because vector3s and quaternions are structs and they're not serialized by Unity by default. They can be shown in the inspector, but they're not serialized or serializable to write into a file. Okay, so instead of vector3, we need to give either 3 floats, okay, x, y, z, or we can just give a float array called position. For quaternion as well, we can give a float array called rotation, and we just give only 4 inputs. But we don't need to save the player's rotation, we just need to save the player's position. So we just created a custom struct. Okay, let's also create a public float speed. Okay, so these are the 2 things that we're going to save. So we created a custom struct for it. Now on capture state, we simply say return new player save data, and we're going to set position to be a new float array. What do I mean by this? We're going to say transform.position.x, transform.position.y, transform.position.z, and comma, and set speed equals move speed, and we're going to give a semicolon at the end. So we returned a new player save data, and we set the position to be a new float array, and it will contain only 3 things, that is transform.position.x, y position, and z position of the player. So because the entire vector3 is not serializable, we are creating a new float array of each float part of the vector3, and then when we are loading it, we'll convert this float array back into a vector3. Okay, so we're converting a vector3 into a float array here. When we are loading, we'll convert this float array back to a vector3. But in the case of move speed, we just set it to move speed. And this is all what we're going to do. Very simple. Let's play the game. Now there won't be an error. we can press F5 to save. Now it has saved one entry. So let's actually look into it. Open with text editor. There we go. Position -1.1, 1.14, 0.87, and unique ID player. And you can see this is exactly the same position as of the player. We just created a save game to file function, creates a new save file, which sets the path. Then we scan all mono behaviors, and whatever mono behavior implements this interface, we just capture its state, converts it into JSON, and adds it to the save file. And at the end, we convert the whole save file back into JSON. And that is why there are two things here. This is the first JSON, and this is the second part. I hope that makes sense. And then we write it all to a text into a file at a path. If this thing does not exist, then it will catch an exception. Okay, now it's time for my tea break. I hope you take a break as well, because it is very boring. But I want it to be intentionally boring. Okay, once we're back, we'll just load the game and call it a day. Now we have to work on loading. Okay, how do we load? We already have a save file. Okay, the save file contains a bunch of different entries, save entries as we call it. Each save entry has two things, an ID and a JSON part, right, which is the actual data. Both of them are string. This is the save file. Now when we load, and I want you to think from this direction. Okay, when we load, we call the save system load. Now what will we load? It only depends on the ISaveable interface. Okay, now whatever object that uses or implements this interface, these are, let's say this is the player, this is enemy 1, enemy 2, whatever it is, we can in a way restore all of the JSON save data for each entity, and the whole thing revolves around this ISaveable interface. Okay, so I want you to get the idea clear, and I want you to implement loading on your own. Okay, if you can't implement loading, at least try pseudocoding, meaning write comments like, hey, load to file or load from file, check for interface and stuff like that, or ISaveable. So I want you to write comments if nothing else works. Okay, no excuses, just do it, because it will help you a lot. Okay, so take your time, pause the video now, and then do it. Hey, Future Anand here. Only during editing did I realize that my audio got switched from my microphone to my webcam audio in the middle of recording. For some reason, Linux did that just to save power. So I already recorded the loading part and then added coins in the project and stuff like that. And I had to delete that footage from the edit. And now I'm re-recording again. So I've edited the project so that we can start again from scratch. There are a few changes. One is I've added coins. You can see there's a lot of coins here. The player has some changes. So all of these are prefabs now. The SaveManager, the player, the coins, all of these are under the samples folder, and I've created a prefabs folder and I've saved it here. Nothing too crazy. Okay, the player has a rigid body component set is kinematic to true. Just keep that in mind here. And then each coin has a capsule collider which has its trigger. So if you want to follow along, you can implement coins in your game. It's just basic cylinders with just a capsule collider, its trigger made into prefab so that you can duplicate. Okay, and we look at how we can load these things which are duplicated, unlike the player. How can we save their data, right? And stuff like that. We'll look into it. Okay, so nothing too crazy. It's just a bunch of coins are added and things are made to prefabs. That's it. There's no other difference because I've edited all of the scripts, deleted a lot of scripts, so that we can start from where we left off. This is the power of editing. So let me actually show you my load function here. So this is the load game to file function. Very simple. We have a try and catch block, just like in the saving, right? This is used to figure out exceptions. Firstly, we get the path so that we can load the file. And we load the file by using the function called file.readAllText. Okay, this belongs to the system.io namespace. So we save that to a string. So file JSON, we call it file.readAllText path. That's it. So this reads all of the text in our save file and then puts it in a string. Now, remember, we converted to JSON twice. Okay, one is for each save entry and the other is for the whole JSON string. Okay, the whole file itself. It's not exactly 2 times, but one is for save entries, which is inside a loop. It runs multiple times. And then one big chunk is being loaded into the JSON string into the file. Okay, that is the one returned to the file. So similarly, we're going in the reverse order. So we have the save file. We are first reading the whole JSON first. So we say SaveFile equals JSON utility.from JSON. When we are writing, we say to JSON. When we are reading, we say from JSON. And this is a generic method, meaning we can actually provide a data type. So we provide the save file. That is what we are writing, right? So we are writing a save file, which is of type save file, the class. So we just load it, okay? And we specify this file JSON as the argument. Now this will convert this string and get data from it, which is of type save file. And save file is a class which contains a bunch of save entries. Now we'll be able to get all of the save entries back just this way. Once we get the save file, then we created a dictionary. Dictionary is a special data type that is a collection of keys and values. So the key is a string and the value is also a string, and it's called lookup. Okay, we created a dictionary called lookup, and what we do is for each var entry in SaveFile.SaveEntries, so we are looking at each entry in the save file. Okay, we just store it in the lookup. So lookup of entry.uid equals entry.json data. And we talked about how JSON data looks like an ID and a value type of thing, which suits the data type dictionary. So we set the dictionary's key to be the unique identifier, okay, inside each save entry, which is this one, and then the value to be the actual JSON data that we want. Okay, so lookup of entry ID equals entry.json data. Okay, then we do the same thing again. We find all mono behaviors in the scene. We include inactive objects. Okay, and we do that by using find objects inactive.include. We will also do that in saving as well. Okay, when we are saving, we can find inactive objects. You can make this a Boolean option serialized to the top as well. And then we iterate over this mono behavior array. If this behavior does not implement ISaveable interface, we continue. And if we don't find the value saveable.uid, if we don't get that value in this lookup, we continue. If we do get it, we are outing it, meaning we are getting that as an out string JSON. So JSON will contain the actual load data. Okay, and then we need to write the code to restore save data. Okay, and we return to true. Okay, we return true previously. We also have cats exception, the same basic thing. Now how do we restore save data? We use the ISaveable interface, and we need to create a new function, and let's call it public void restore state, which takes in an object state. Okay, but better, because we know we are loading JSON, we know specifically that it is of type string. So restore state will take in a string state. Okay, now how do we restore data? We can say saveable.restore state JSON. It's as simple as that. We are done with loading the data. So now there are a few errors for the player controller. Now I can press Control and period or quick fix on VS Code, or you can use Alt and Enter on Visual Studio and implement the interface. Now we have restore state function which has a state. Now how do we restore that state? Remember, we are saving the player save data. So we need to get back that player save data. So we need to say player save data equals JSON utility dot from JSON. We use from JSON on individual level. So in the saving system, when we are saving, we used 2 JSON initially on each ISaveable, and then we saved the big 2 JSON. In loading, we use the from JSON, which is the big JSON, and we are looping through each restore state. And inside restore state, we restore the specific data type that we saved. Okay. So now we can say vector3 position. Instead, it's better to directly set transform.position equals new vector3 save data dot position 0 1 2, which is the xyz which we saved here in this float array. Okay. And there's one more thing that we need to load, that is move speed equals save data dot speed, and then we add a semicolon at the end, and we need to add a semicolon here. So now we have successfully restored the data of the player. Very straightforward. Now we're going to ignore the coins here. I can move, I can press F5 to save one entry and then stop the game. And now because we have this load data in F6, immediately teleports the player. Okay. Let's also check with the move speed. Let's actually change the move speed to -3. F5, I saved it twice out of habit for some reason. Now I'm going to press F6. It immediately teleports and move speed is -3. Okay, it was 5 in the beginning. So now we can see that loading is working. Great. There's a problem with this approach. Okay, now we are completely relying on this path, which is fine for saving because if this thing doesn't exist, it will create it. But in the case of loading, this needs to exist. So it's better to actually cut this statement, paste it outside this try block. Okay. Then we can say if not file.exists path, meaning if the save file is not found in path, we just give a log warning. In fact, it should be a log error. Okay. Now it's a lot better. Cool. Now one more final issue with this saving system, and that has everything to do with the UID. In the case of the player controller, we can say UID player. In the case of a coin collection script, we can say coin collection or something like that. Or in the case of game settings, you can say game settings. But what about coins specifically? How do we add unique IDs for duplicated objects? Okay, how do you do that? You typically should not save data of spawned objects because those are things created at runtime. And if you try to save data of a runtime created object, you shouldn't. You're doing something wrong. Okay, because when you're loading, that runtime created object may not be there. So you need to take that into consideration when loading runtime created objects or spawned objects. But duplicated objects will always be there when the scene loads initially. So how do we deal with that? Firstly, let's make sure that these coins actually work. Remember, these have a capsule collider with S trigger in it, and the player has a rigid body component attached. So let's actually create a script for just coins. Okay, coins, very straightforward. Just for the collection mechanics, I'm going to say on trigger enter. If other.compare tag player, we can set game object dot set active false. We shouldn't destroy it. If we destroy it, then we can't save it. We can save inactive objects though. For coins, it's better to not activate them. Now what should we do before this? Increment the player's coin count. I hate it, but I also love it. So how do we increment the player's coin count? Should we add a new field in the player controller? No, because that's not good practice. You can do it, but player controller ideally should not have anything to do with coins because it's related to movement. So we create another script for coin collection. Let's call it coin collection itself. Another mono behavior script, coin collection or collector, whatever you want. This one contains a public int coin count equals 0. Actually, let's make it private because It shouldn't be public. And then we can say public void collect coin, and it just updates the coin. Very simple. Now in the coin script, we can say other dot get component coin collection dot collect coin. We are using get component because we know for sure that it is the player and the player will contain a coin collection script. Really straightforward. Okay, the player has a tag player which I already assigned while recording previously. Really cool. Let's actually go to the prefab of the player and add this coin collection script. Simple as that. And on each coin prefab, let's add the coin script. Okay, very straightforward. Now if we play the game, if coins are deactivating, it means they are being collected. Great. Now this doesn't do any saving and loading. In order to save and load, what should you do? I want to save the coin behavior and the coin count. Okay, I want to make sure that all collected coins are not loaded again when we are loading the game. So how do we do that? Again, just have a think about it. So whenever you want to add saving behavior, the only thing that we need to add to an existing class is the ISaveable interface. This one. This is the only thing that you need to care about. Okay, then everything else comes automatically. In the case of coins, we can implement ISaveable. Now, out of good habits, we create a namespace, SaveSystem.samples, and put it inside there. So Control A, Control K, Control F. The same, let's do that with coin collection script. Put it on a namespace, SaveSystem.samples, Control A, Control K, Control F. Save it. Now this one has an error because now we need to implement this interface. So we need to click on this control and period on VS Code and implement interface. Really cool. Let's do the coin collection thing first because it's very straightforward. We can just implement the ISaveable interface, click on it, control period. We need to use the SaveSystem.runtime, control period again, implement the interface. So here we can give a new ID called coin collection. And in the case of object, we need to return something that is not return coin count. The AI made a mistake. Okay, because we are returning an integer here. We cannot return an integer because we cannot specify an integer in this JSON utility.from JSON. We cannot specify an integer. Even if we are just giving an integer or we need an integer, we need to create a separate struct for it. So only two steps: create an ISaveable interface, create a struct. Okay, and you create the struct because you created the ISaveable interface. So here we can say public struct. Let's call it coin save data, and it only contains an integer coin count. Now instead of returning coin count, we return a new coin save data where this coin count equals this coin count. I hope that makes sense. Now in restore state, we need to do the reverse. We need to actually from JSON, right? So what do we need? We need coin save data equals JSON utility dot from JSON coin save data state, and simply coin count, which is this one here, we are setting it to be the save data dot coin count. Now the coin collection script would also be saved, but not the coins. The coins are different because if I press control and period and implement this interface, you'll have some difficulty with the unique ID because these things are duplicated. You cannot duplicate the same ID. It doesn't make it unique. So how do we do this? Two ways you can do this. And how do you figure out these two ways? We can say Unity generate unique ID, and you can go to AI overview and you can see how this thing works. Okay, and it's very simple. It's just a simple function called GUID dot new GUID dot toString. So you can say GUID dot new GUID.toString. Okay. And for some reason, it added the Unity editor namespace, which is not needed. We need the using system namespace. And the reason why it is because it should be GUID in small. GUID should be small letters. I actually use capital letters. Now this will generate a random unique ID for each coin. Okay. You won't be able to say this in the inspector, but you will generate unique ID for the coin. But the problem is there is a slight chance, very tiny chance that two objects may have the same ID. Okay, because it is randomly generating an ID, there is a very teeny tiny chance that two things could be the same ID, but statistically the chances are very rare. Okay, very rare. It's not even very rare, it's ultra pro max kind of rare, but it is still possible. So that is the downside with this. But you can use editor scripts and onValidate functions, which I've used in my anchor save package, to prevent that from happening. That is completely up to you, but there's a simpler way to do this, and I only thought about it while recording the previous video. And that is to just say stuff like coin space plus transform.position. It's as simple as that. .toString. So for each coin, just to specify that this is a coin, we just add coin, and we just add the current position of the coin to it. The only issue with this is if you accidentally duplicate a coin and then keep it at the same place. That way, two coins can have same data. So that is the only potential downside to this. But if you work good enough, this is more than enough. But I recommend keeping GUID not .new GUID.toString, because the other one where you accidentally duplicate and stack two objects on top of together has a higher probability of happening compared to this. Okay, so you can just use this function to add a new GUID. Of course, you can add editor scripts on top of this to make it so that this is never the same. Okay, now how do we capture the state here? Again, we need a struct. We cannot just give an integer. So really simple, we can create a boolean here saying collected equals false. When this thing gets collected, we can set collected equals true. Very simple. So public struct coin save data. It is clashing with this coin save data here. Let's actually call this coin collection save data here. And we just need to have not a coin count, but public bool is collected. It will save whether it is collected or not. Because the count is already collected here, the namespace SaveSystem, I don't know why it also renamed this one here for some reason. We have coin save data in the coins, which contains NS collected, and then coin collection save data, which contains the coin count. Now, simply in the capture state, again, let's practice. In capture, what do we need to do? We just need to return something. So we can say return new coin save data, and we set is collected, which is the property in the struct, to be the current value of the boolean. So if it isn't collected, it will be false. If it is collected, because we're changing it here, it will be true. Okay, that is what we're returning. Now what will happen in restore state? So we need to do the opposite. We need to read from JSON. So we can say coin save data equals JSON utility dot from JSON coin save data, and we give in the state, and we set collected, which is this variable here, to save data dot is collected. And because we are loading, we might as well set active to not collected. So it will disable the game object on load if it is already collected. And let's test for errors. No errors, great. Remember, now there are 6 coins. So if I go over here, collected 2 coins and press F5 to save, it saved 8 entries. Why do you think there are 8 entries? Even though there are only 6 coins and a player, it should be 7, right? Why do you think it was 8? The reason why it was 8 is because the player contains two ISaveables. One is the player controller, the other is coin collection. So both of these are saved as separate entries in the save file. I hope it makes sense. Okay, now let's actually open it and see what happens. So let's copy this, go to the files, and you can see unique IDs are generated for each coin, and you can see the probability of two of them being the same is very, very low. But you also have a save entry for the player and another save entry for coin collection. So this makes it easier to debug, because now when you're saving and loading, you actually have a save file that you can look into, okay, and you'll see what went wrong. Very simple. Okay, this is why JSON data is very easy to debug, because you have great idea. If you were to use the transform.position printing instead of UID, it also adds to the benefit, because now you also have the data of which coin exactly was added. We can close this and let's stop the game. Now, if you go and play the game again, this time we need to check if it is loading or not. I can press F6 and haha, load has been successful, but loading did not work. The player has been loaded successfully, but the coins have not. Okay, so let's see what's up with that. So let's go to the coin. Actually, let's debug it for ourselves. Let's open the save file, and you can see true and false values are added here. So two of them are true, meaning is collected. Two of them should be collected. So there is something that is going wrong somewhere here. We have coin save data is collected. So when we are restoring, let's do this. Debug.log coin collected state equals collected. Very straightforward. Now we don't even need to update or save again. I can simply press F6 and that line of code is not being run. Collection is working, but restore state is not being run. And why do you think this was the case? Have a good think about it. It's because of this UID dot new GUID dot toString. So whenever we are calling this UID, which is in this save system load here, when we use this UID, it is actually generating a new ID. That is the actual reason why it is not loading. Okay, so how do we not load it? We can simply cache it. Okay, the problem with caching is we need to make sure that things are not regenerated again, meaning we have to work with editor scripts and stuff like that to validate it. I'll show you how you can do that in just a little bit, so that if you want to use this approach, which is something that I believe is better, you can do that. So I'll show you how it works in my original project. So here in my original project, I actually have, if I go to packages, if you do install the Anchor Save package, you can go to this packages window, Anchor Save runtime. There's a class called persistent ID. If I open it in VS Code, this is how I do it. Just to show it to you, persistent ID. Firstly, we disallow multiple component. This is an attribute that comes with Unity, and this just disallows multiple component. Then we have a string ID, which is hidden in inspector, and it has serialized field, and then it has another property called ID. In awake, if this ID is empty, meaning string.is null or empty, then there is a persistent ID missing on this. The object cannot be saved, just a log error. But the main core comes here. This is technically an editor based script, so I've used the preprocessor directive Unity editor. So if Unity editor, we can use the onValidate function, and so we cannot generate IDs on prefab assets. So prefab utility.s part of prefab asset, these are functions. We just simply return if this is missing, or if it is empty, we generate a new ID and then set the editor utility to be dirty so that it refreshes the editor. Or we can just ensure unique, which just checks if it is a duplicate or not. Okay, if it is, a duplicate, we just generate a new ID and then set this as dirty and mark the scene as dirty. A lot of stuff you can copy if you want to. And generating the new ID is a simple function that just uses the same function that we just used. So this is a much better way of handling this. Okay. And it runs only on the editor. This has no overload in the play mode. So you can use that, and here you can just simply get component persistent ID and get this ID string. Okay. So that is one way to do it. For now, temporarily, I'm just going to say coins plus transform dot position dot toString. Really simple. And then hit save. This will work. So let's play. Let's collect these 2 coins. Go over there. Press F5 to save date entries. Nice. Play the game again. Let's press F6 to load, and you can see that the coins have been collected. That is great. We can simply remove this debug.log statement because we no longer need it. And let's take a look at that particular save file. Let's reload this save file, and now you can see these are going to be unique IDs. If you want to be extra secure, just to avoid this duplicate issue, we can just simply add name, or better, add a space and then add a name. That's better. So you can do this if you want to reduce the probability of getting duplicates, because now if you duplicate, it will add this bracket thing to the name, and that makes it a unique object. But it's bad because you don't need that duplicated coin data. So it will be a bug in your game, because when you collect that coin, it will look like you have collected 2 coins. So technically you don't and you shouldn't have to need this. Okay, cool. And that is it for saving and loading. We just created a very simple saving and loading system in Unity. You can now use this as a working base. However, I recommend using the anchor save project as a base to extend your own saving system. This is just purely educational in nature, just to show you how things work. But yeah, this is how you build your own save system. Okay. And now you can work on top of this, whatever things that you have in mind. I recommend updating this SaveManager script, because now you can have different types of save modes. All of these are there in the anchor save project, so you can extend on top of that. That is what I recommend. But you can also do crazy stuff with it. You can add your own events. You can make this a part of your game, something that is triggered by a dialogue or something like that. You can make it happen. So yeah, if you watched this entire video, you now understand how a simple save system has been built from the ground up, how to break the problem into parts, how to plan before we execute or write code, and how JSON saving actually works at a very basic level. Of course, this isn't the only way to do it, and it's not meant to cover every edge case. It is only meant to give you a solid mental model you can build on, modify, and even throw away when your project demands something more advanced. So take this, experiment with it, have fun, break it, adapt it to your own game. Just a quick mention, I do provide one-on-one Unity sessions coaching if you're interested, on Discord or any platform that you require. Of course, it is a paid session. The details will be in the description. Or you can just comment on this video if you're interested. Let me know what you would like to see in the next video. I will be making a free course on memory profiling soon. I already did record it, but my SSD and hard drive crashed on me, so I lost all of the data. So if you are interested in memory profiling and what exactly is memory and things like that, let me know in the comments below. Thanks for spending the time, and as always, take care. See ya. Bye bye. I love you guys. Ciao.